All right, welcome back, Art22. All right, today we are talking about something called the for loop. Now, a loop is a bit of a trickier thing to get your brain around first. It's a little less intuitive than some of the other things that we've been looking at in code, but it ends up being one of the most powerful tools that we can use when writing code, and it's something that we're going to be using constantly throughout the rest of the quarter. So even if it takes a while to kind of sink in at first, don't worry, we're going to be getting tons of practice, and we're going to work on this today, and really pretty much every week we'll be using this. Okay, so what is a loop? In code, there's a couple different types. There's a for loop, there's a while loop. We're going to be looking at just the for loop today. Now, what does this mean? So let's say, not inside code land, you wanted me to wave 5 times. You might tell me, okay, Mark, wave 5 times in a row. And I'd go 1, 2, 3, 4, 5. All right, so what you just did is basically what we're going to be doing in code. You wanted something to happen a certain number of times and then stop. That is what a for loop does. So you could have maybe phrased it a little bit more code-like and said, hey, Mark, when I'm counting from 1 to 5, I want you to wave every single time I count. And you'd be like, 1, 2, 3, 4, 5, and we're done. Okay? So that's basically what's happening with the for loop. Now let's take a look at how this gets structured in code, because it looks a little scary at first, but I think we'll start to get a sense of how it's working. And also the nice thing is it's almost, not almost, it will always be in the same format the way we write our for loops. So let's take a look at this in kind of a handwritten pseudocode-ish state. So let's say we wanted the thing to happen is mark wave. Let's imagine that that's a function, mark wave. Okay. So what we need to tell, if we think about what I just had you do, was tell me to to wave while you count from 1 to 5. So what are the elements of that? Well, there's the thing that's actually happening, which is me waving. So that's going to be in there with our mark wave function. But I said that you need to tell me when to do it. And we said to do it from while you're counting from 1 to 5. So we have baked into that idea that there's something counting for us. So counting from 1 to 5. And so that's how we structure our loop in code, is we have a variable that's going to count for us. And then we basically just set some conditions. So for example, count up by 1, 2, 3, 4, 5, but stop when you get to 5. So let's look at how we might write that in a code kind of way. So let's say, so we said we want to start our counting at 1. So we need, because we're going to be keeping track of that number, 1, 2, 3, 4, 5, we need a variable to keep track of that count for us. So the convention for loops is to use the letter I as our thing keeping track of what count we are on. So we're going to say int I, and we're going to say that it equals 1. So we're going to start counting at 1. Okay, cool. And then we put a semicolon. All right, so we know now that we have a variable called I, an integer I, that's going to be keeping track of what count we're on. And we know that we're going to start it at 1. Now we said that we wanted it to stop at 5, so that I wave to you 5 times. So there's a couple ways we could think about telling it when to stop. The way we're going to start to look at it is we're going to use something that will look a lot like our conditional if statement. So we're going to say when I is less than 6. Because if you think about it, when I is less than 6 accounts for 1, 2, 3, 4, 5, we're still less than 6. But then if we were to count one more, 1, 2, 3, 4, 5, 6, well, 6 is not less than 6, so that means we're done. We stopped. We've reached that condition where we no longer want mark wave function to happen. Okay, so those are our first two components. We start with an integer called I, and we're going to say we're going to start it at 1, and we're going to go until while it's still less than 6. And then the last part of our loop is we just need to tell it how we want I to be counting. So we've kind of already implicitly decided that we want it to be counting up by 1. We want to go 1, 2, 3, 4, 5. You could have done it by 2s, 1, 3, 5, 7, 9. You could count up by 10, 1, 10, 21, and so forth. But we just want to count up by 1. So we're going to say I equals I plus 1. So basically every time our loop happens, we're going to increase that counting variable I by 1. All right, so quick recap here. We want me to wave 5 times, so we need to keep track of that count. So we make a little variable called I. We set it to 1, because that's where we want to start. We want it to happen 5 times, 1, 2, 3, 4, 5. So we want to tell it to stop when I is less than 6. So while I is less than 6, keep going, but once it gets to 6, stop. That's what's happening here. And finally, we've already kind of inherently decided this, but we want I to count up by 1, not by 2, not by 3. Okay, so now really the way to package this for the syntax of the code, the way we're going to write it, how I've written it is actually basically what we want. All we have to do is add for, a parenthesis, and then some curly brackets. So that should look a little bit like our if statement. So this bit of code here is basically saying for when I is 1, and while it's less than 6, count up by 1. And each time you count up by 1, do whatever inside of here. So we start our loop, I is equal to 1, mark wave. Now increase I by 1, I is now 2, mark wave again. Now it's 3 times, mark wave. Now it's 4 times, mark wave. Now it's 5 times, mark wave. Now it's 6 times, oh, that's not less than 6, so we're done. That is the for loop. We're going to use it a ton. If it's not totally clear, don't worry. Tons of practice coming your way. Probably more practice than you want on the for loop. And but let's go ahead and put it into code and actually see how this thing happens in our processing sketch. Okay, here we are with a fresh processing sketch called Week2 Class1B. And let's go ahead and add our normal things. We want a setup section. We want a draw section. And sure, let's have a size, why not? Fun fact, I think if we were just to run this, there is some default size that processing gives us, which is being blocked by a bunch of things right now. Okay. There we go. So by default, processing gives us some size, but that's neither here nor there. So let's say size, let's mix it up this time. How about 800 by 400? There we go. Okay. So let's now put in that loop that we just built outside of code into this setup section. So if you remember, we had the thing we wanted to have happen was mark wave. It's not a function, but let's ignore that for the moment. And now we said we needed those 3 parts of our loop. So because it's a for loop, we'll start with the word for. Turns green, that looks good. And now, if you remember, we said that we needed to have our variable I keep track of how many times we've done this loop. So we're going to make our int I, and we're going to set it equal to 1. Okay. And we decided that we wanted our loop to keep going while I is less than 6. So I less than 6. And we also decided that we wanted to count up by 1. So we're going to say I equals I plus 1. Okay. And then you notice I put a curly bracket here, and we need one more down there. And I'm going to go ahead and do that Command T thing that we talked about before, which is our auto format. And it shows that we kind of indented here to kind of make this for loop a bit more clear. Okay, so, mark wave, as much as we wish it was, is not a function. So let's put something that actually works for our code. So why don't we do this, just to keep things in the most kind of minimal for loop possible. All I want our for loop to do is actually print our integer I. So let's do that. Print I. Let's see what we get. Okay, there we go. 1, 2, 3, 4, 5, and no 6. So that did exactly what we wanted to. We started our loop, and we did whatever was in here, which happened to be printing. We did that thing 5 total times. And the thing keeping track of how many times we did it was our I variable that went from 1, 2, 3, 4, 5. Now let's just explore, what if we wanted this to happen 10 times? So maybe I would say we're going to go from 1 to 10. So we're going to stop right before we get to 11. Okay, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Okay, so that's working pretty well. All right, so now 2 little adjustments I want to make to our for loop. Mainly because it's both a convention in programming, and so if you see it elsewhere, it'll be good to start to structure your loops in the same way. First thing is that a lot of things in computer science are what we call index 0. And that's basically a fancy way of saying we tend to start counting with the number 0 instead of 1, which is a little bit weird sometimes to get your brain around at first, but we're going to see why it's important later on, especially when we get to arrays. But we want to kind of generally think about starting counting things with 0 instead of 1. So let's change the initial number of our I variable to be 0. Okay. Now, with that change, if we're going to start counting at 0, doesn't really change how this is behaving. It just means that we need to make an adjustment if we still want 10 things to happen. Because if you think about it, if we start at 0 and increase by 1, and we go while I is less than 11, we're actually going to get 11 things. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's actually 11 distinct counts. So let's bring that down to 10, and let's print this out just to see what we get. Okay, so now we can see that we started at 0 this time, and we go all the way up to 9, which, despite what it kind of looks like because we ended at 9, is actually 10 things, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is more of the convention. And in some ways, while it's a little bit weird to start counting with 0, it is kind of nice to know that when you do I is less than 10, that to me is a little bit helpful because now we know that this is how many things we're actually getting. So if that was 100, and I'm starting with 0, I know that I'm actually getting 100 things. Even though we end with our counter being 99, starting with 0 means that this middle part is actually how many times your loop is going through it. So if this was mark wave, I would have waved to you 100 times, and this lecture would be much longer than it needs to be. Okay, so one other adjustment to the loop that I want to make, which is this part. So there is a bit of a shortcut that we can use to make this written a bit more efficiently. So I equals I plus 1, that's saying whatever I is, add 1 to itself. So if I was 0, then we're going to say 0 plus 1. If I was 1, then we'll say 1 plus 1. Now there's a bit of a quicker way to write this, which is simply I plus plus. So I plus plus is exactly equivalent to saying I equals I plus 1. It's just a lot faster to write, and you'll find that when we're making a bunch of loops in the future, this happens to be very, very nice just to be able to do that. Let's confirm that this is still working the way we think it is. Yep, still going from 0 to 99 by 1. Okay. So let's do one more loop here. Because so far we've been counting up, but we could count down if we wanted to. It's more rare that this would happen, but let's make one more loop that counts down. So in this case, we want to say, we still want to do something, let's say 100 times, but now we're going to say we want I to start at 99, and we want to, actually let's do it, sorry, let's go, I is 100, and we want to go until, or let's say while I is greater than 0. So while I is greater than 0. And now you might be guessing correctly that we could do two things here. We could say I equals I minus 1, or let's just go ahead and immediately do the fancy version, I minus minus. So this means subtract 1 from I every single count of our loop. Okay, let's put some curly brackets in here, and let's print I again. I'm going to comment this one out, so we're just looking at this loop now. Okay, great. So we started at 100, and then we went down to 1. Very cool. We could make it match this one a bit more if we wanted to get from 99 to 0. So we could say we start at 99, and while I is greater than -1, because that means that we're going to go down, 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 including 0, but 0 is still bigger than -1, so we get 0. Let's check that out. 0, and we started at 99. Great. Okay, so that's our basic intro to loops. Let's get a couple comments in here, and then let's actually do something interesting with loops, because printing out numbers is not exactly my idea of a good time. So we'll say start counting at 0 and go and keep counting, keep looping while I is less than 100. And then kind of the same thing for this one. Start counting at 99 and keep counting, looping while I is greater than -1. So 99 all the way down to 0, but we stop because -1 is not greater than -1, which is another of my deep statements. Okay. Cool. Okay, so let's get into something a bit more interesting. Let's say that instead of, I'm going to comment this one out for now. Let's say that instead of printing something, we want to actually draw something with this loop, which is really why we're doing this whole thing, is that we want to use the power of doing a bunch of things to draw something. So let's go ahead and get crazy here and combine both the randomness that we talked about last lecture with this idea of using a for loop. Okay, so let's say outside of the for loop, imagine, here, let me switch over here. So imagine that I wanted to make two rectangles in two different positions. You know, that's not too hard, right? Like, let's say we have our window here. I don't know why I always draw these buttons, but it seems very important. Okay, so we have our thing here. And let's say we wanted to draw two rectangles at a random position. Like there and there, maybe. Okay, so how would we do that? We'd say rectangle. We'll come back to the position, but maybe we know that we want it to be 20 pixels by 20 pixels for each of them. Rectangle 20 by 20. Okay. And then what we need to do is figure out how to put randomness into the x and y part, into the coordinate part of the function for rectangle. And so, if you remember from last lecture, we were able to use processing's random function to give us some random numbers. So what we could do is, inside of here, we could say random. And now we need a range for our random, because remember we need the lower limit and the upper limit. In this case, we're trying to draw these shapes within our window. So it would make sense that our lower limit would be 0, and that our upper limit would be either width or height. So, for example, in this, for the x part of our rectangle, we could say 0 to width, so anywhere within our screen. And then for this part, our y part, we could say 0 to height. And that would give us a random number that fits within our window. And then we just do the exact same thing for this second rectangle, and voila, we'd end up with two rectangles placed at random positions. Now, that's all well and good if we just have two rectangles, but we want to be a bit more ambitious than that. If you imagine we wanted 100 rectangles, all in random positions on our screen, this method here would be very tedious, right? Writing that line of code, rectangle, random, 2020, 100 times, like, I don't think I would code if that's the way we had to do it. Luckily, as we've just seen, if we want to do something a bunch of times, the way to do it is with loops. So let's go ahead and implement the kind of not cool version of making a random position rectangle like twice, and then let's convert it into the loop version where we can do it as many times as we want, or as many times as our computer can handle. Okay. So here we are. Let's say we want that rectangle to happen. And we decided that we can make it at a random position by saying random 0 to width. That's our x coordinate. Now our y coordinate will be a random between 0 and height. And now we can say, let's give it just 20 by 20 for the dimensions. Okay, let's run that and see what we're looking at. Okay, so we see that we got two random numbers. Don't know exactly what they were, but there we are. It's kind of like maybe, I don't know, 50 pixels over, maybe like 500 pixels down, something like that. No, it can't be 500. 300 pixels down. All right. let's do that one more time. So we'll make another rectangle, new random number for each. Let's see what we get. Okay, great. So now we see that we have two rectangles, and this illustrates to us that each time we use the random function, we're getting a new random number. It's not like we make a random number here and it's going to be the same one down here. Every time we call random, it is a new random number. So this is well and good, but you can see how tedious this would get if we had to do it a bunch of times, right? So let's go ahead and use our loop to make this much more efficient. So I'm going to comment this out and say, don't do this. Instead, let's use our cool new loop approach. I'm going to comment out our print for right now. I don't need to see all that. And now let's get 100 rectangles, right? Because this loop is doing something 100 times. We printed 100 things before. You guys made me waves 5 times. Now let's make it do 100 random positioned rectangles. Boom. Okay. Now that is much, much cooler, right? And I think this should start to highlight the kind of why we do computational art, right? We get to harness this kind of power of doing something a bunch of times and introducing randomness and variety and complexity with, if you think about it, what, like 3 lines of code basically, really 2 lines of code. This one here where we set up a loop, and this one here where we said make a random rectangle. So from 2 lines of code, we just made a pretty, relatively complex image just from that. Okay, let's do a few more things with this before we call it a day. First things first, I'm a little bored with our white rectangles. Why don't we use randomness to affect the color as well? All right, I know we're getting kind of crazy here, but hang with it. So let's say that first things first, adios stroke. I don't want any stroke, no outlines for our rectangles. Okay, but what I do want is a random color for our fill. So we know that we changed the inside color by using the fill function. And now we know that we need, from our previous lecture, an R value, a G value, and a B value, red, green, blue. And if we really want them to be random, we can actually just use the random function to have processing decide what the colors are going to be. So let's say we want random. Now let's think about what the range we want is. So we know that RGB has a value between 0 and 255, with 0 being all the way off basically, black, 255 being all the way up. So let's make that our range, 0 to 255. So there's our red. And I'm just going to make this a little bit easier. I'm just going to copy this 2 more times. There's our green. And there's our blue. Okay. So now what this loop should be doing is still making 100 things happen. It's still doing whatever is inside of here 100 times, 0, and while it's less than 100. But now we're saying, all right, no stroke, no outline. And we're saying each time we draw a new rectangle, let's get a random color, random fill color, and let's draw rectangle at random position. All right, let's see what we get. All right, cool. We are in like Easter confetti mode here. All right. Now, one more thing I want to do to give a little bit of more depth to this is let's add in some of that transparency that we'd seen before. So if you remember, if we give color one more argument, that's going to be the alpha channel. That's going to be the how transparent is our our shape. So I'm going to give it something relatively low, maybe like 80, just to give it some of that kind of 3D depth. Yeah, that's cooler, because then you get things like this, right, where we can definitely see the overlap a bit better. Maybe, do I want a background? Let's not worry about the background right now. Okay. So that's pretty cool, right? So in basically 4 lines of code, we've now made 100 rectangles of random color in a random position. Let's go a little bananas here and let's make 1,000. Sweet, okay. Let's go extra bananas here and let's do 10,000. Very cool. So now we're kind of pushing past the threshold of starting to think about this as like almost like a texture, I would say. This to me now feels more like like a less of distinct shapes. I mean, you can kind of still see them, but we can start to venture in the land of kind of generating a texture. Okay, so let us do one last thing with our for loops that I think will blow your mind. Let's go back to 1,000. Now, you've probably noticed that we have our draw section down here that's been kind of lonely this entire lecture. We've been putting everything up here in the setup, which means it happens exactly one time. So this loop, which makes 100 things, or now 1,000 things happen, only happens one time. Okay, that's why it's kind of static, right? So we drew 1,000 rectangles and then we stopped because setup only happens one time. What would happen if we decided to copy that, I'm going to comment it out, and put it down here? Because we know that the draw loop happens over and over and over and over again. So what should happen is we're drawing 1,000 rectangles, but we're doing that over and over and over again, and they keep getting random positions and random colors. So here's where we're going to start to get some really dynamic behavior, which is why we can see how powerful these for loops are. All right, there we go. So now we are generating this dynamic, randomized texture. The colors, the position, everything's changing. Maybe that's even more texture than we want. Let's scale this back. Let's bring it down to like, how about 150? Oops. Actually, let's keep it at 1,000. What I really want to do is one last thing. Let's say we want to add one more bit of randomness into this. And that is, we had this kind of static 20 by 20 rectangle. Let's say we want the dimensions to also be random. So we're just going to go like full random mode. There's nothing that's not left to chance here. So let's say that our width of our rectangle will be a random number between maybe 10 is the smallest we want it, and how about 100 is the biggest. And let's just do the same for our height. So we want our height of our rectangles to be somewhere between 10 and 100. And let's just check out what that is. All right. So, you know, definitely a related texture, but we're starting to see some variety in the size of it, which ends up giving a different character to this texture that we're creating. Okay, so that's where we'll leave it today, but I always find this lecture exciting because I think we're starting to see the potential for using the power of computation to make things that would be very hard to do like manually, or even in a more tedious way, like when we were thinking about if we wanted 1,000 rectangles, having to write out each one. Like imagine being in Illustrator or Photoshop and having to drag in 100 or 1,000 rectangles. It would take forever and wouldn't be very much fun. But in a couple lines of code, we're not only able to generate 1,000 rectangles, but we're able to vary their position, their shape, their color, continuously. And I think we'll see that this is really the first good taste of why we're doing this whole computer programming for the arts thing in the first place. So go ahead and play around with that, see if you can generate different textures, change the color, the shapes, use ellipses, you know. So a whole lot you can do with this, and just explore and have a little fun. All right, we'll see you next time.